Let's play some lo-fi. ये करना है क्या सॉल्व? Insert a node and delete a node. Okay. Guaranteed. So search. Not node then return. So it depends on value, right? So if value is node.val and return node, else if value is greater than node.value, we're left with only one possibility. So in that case I can go right, but the thing is the value does not exist. I can also do this. Let's think about it. So I have to store 5. Just gonna go right. Then 7 is greater. Wait, what? 5 is greater, then it will go left. If I store 5 here, then there is going to be a problem. Five is bigger now. And it should go right now. The fuck? So it will go right, then left, but left does not exist. This will return null. So this will be null, this will be null, this will be null, and then this will be null. What should I do? In case of a null, I can return पीछे वाली node, the node before. That will be fine. Much better. Okay, so if it exists, then only else return node. I think what I'm going to get. Element. I got 7, which is fine. In second case, what I have 40, 20, 60 and 30. This is my I have to store 25. So I have to go here. It is returning 30 now. I can put here. We got null, null, then value. Fine. Let's store this value in a variable. And let's see if it is greater than the given value. What is value? Okay. Let's say in this case it's bigger, then I'll store in a left. So node.left should be tree node, and I can store value. Else the same thing to the right. And after doing this, don't have to do anything, just return root. That's it. What's up, Adit? हो गया. So again for null. Hope that works. बस यार एक नंबर. Wrong answer. Expected what? अच्छा. Okay. If it's null, then just make a node. Pre-node with the value and return. Good stuff. Thanks, man. But what if I have a duplicate? In case of a duplicate, I can probably put in both sides. Or I have to store it like in a same level. But I can't do that in a binary tree. Whatever. Cool. Next is to delete a node. Search for a node to remove. If a node is found, delete the node. Okay, but how? So if I delete 3, then this will be bigger. So I can make a link between these and these. This is what they did. Is there any other option? Or I can do this like दो का link बना के इसको right से connect कर दूँ. That is also possible. One valid answer is it's also accepted. हाँ, so 5, 4, 6, 2. So 4 यहाँ. अच्छा हाँ. But if I put 2 here, 6, null then 4. Both ways, it's the same thing. Let's just find a node. Oh. I have a value key. What if key is not here? Each node has a unique value. Root is a valid search. Okay. It's gonna be same code basically. मैं copy paste कर सकता हूँ if I want. Let's just copy this code for a search. Done. I can search for this. What if it's null? Search for root and store the value in the node section, and let's see. Value is not defined. Cha. I'm getting this. Fine. And second example, key is 0. Does 0 even exist? but it's also possible. Here I got this. If this is null, then just return, right? I think this will also give me null, so it should be the same thing. This is probably right. Yeah. Now let's do this. I have this 3 which completely matches. I have to remove. What I have to do, I have to take the right and link this with the left. I also need this. Can I just change the value of node? I need this. Should I? What I need root and node, both of these. In this case, if first value is matching, then maybe I should do this in my VS Code. Take this example, put it here. Let's see what we have. I have 2 objects. First one. Wait. I have 3 and I should have what? Are these same addresses? Yeah. Because of this. Hi Harish. How can I fix this? First of all, यहाँ तक तो कभी पहुँचने वाला हूँ नहीं. I will never get null because the value exists. Why not go directly? Because I can debug. That's why. I can push like 2 arguments here and I can maybe. Is there another way around? I can maybe. So let's do this. Node equals. This one I have to delete. What if there is no write? Okay. If write exists, then I can do node equals to node dot right. I think this is fine. Creating the testing and passing them into a function. Yeah, that's true. So if write exists, then I can make this node this. Then after doing this, wait. So node is now 4. I have to do something. Let's I'm doing okay. Let's do this. This is just a pointer, right? Do this. I need this value, the parent of 3. Should I create a dictionary to store parents? Can you solve it with time complexity of height of tree? I think that is possible. By the way, if I just do this, what will be the answer? I should just check. I got 3, I got 5 and 3. So 3 is still here. This is not going to work. Hello. I also need parent to the node. And Hi Ayush. How can I get parent? I think I have to. I can create a list, maybe, and here I can do list dot append, but you have create a new function like in order to find the next node to replace the current node. Acha, like what is your method of solving it? What I'm trying to do is just find a node. So if it doesn't exist, then just return the root because the key doesn't exist. If it does, so I made this function, so it gives me the value of a node. So if key is 3, I will get this 3. The problem is I also need parent to link these two, right? And then link this. Leetcode question, not this question. So what's your method? My method of solving is read a question and just try to find a algorithm. Create a new function like in order to find the next node to replace the current node. So if this is null, wait, what? What do you mean by swap? What if we have another tree like 4? Right? That case we have to get the greater value. Acha, subtree from 4. Let me figure this out. We can get greater than 4 in that subtree. That is also true. Makes sense completely. So if I have to delete 3, and I have to go to the rightmost of 3 to find the greatest value. Let's do this. I have to explain you the question. I can do it right now. Where is that? This one, right? This one, na? So basically you have to write an algorithm here. So you have a tree. You have to convert this data into a string. So what I did is, see, I tried one method. I tried to convert this into in order and pre-order. But if you have ambiguity, if you have, these values are repeating, then you cannot generate a unique tree from that method. So probably the next method I have used, which actually worked, was convert this into level order. Just do a level order traversal. And so what I did here, level order traversal, as you can see, and I stored this data into a string because I have to, return the value in form of a string. Then what I did, so I got all this data here. Then I have used basically these functions to actually make, a proper array from that data. And after I made that array, I have just created a tree from that level order traversal. So creating tree is very easy. You have like this is your root, and this is left and right of this, and then you have these, and this is left and right of this. This is this. So you can create this algorithm to store this. It's easy. And then you can just return the tree. That was it. I think if I'll connect these two, just इसके right वाली, then I can store 2 to the left. But if we have like elements to the left, I have to arrange properly. Yep. If I put 6 here, then Got this. I have this. I need to connect these two. I have to go as left as possible and connect this. So we have this, and this will go left. So it's returning something. If it's null, then I don't have any node to the left. But if we do have something, then this will return none. And I need a node. Fuck. Why only need right? I'm trying to go as left as possible. I just took right and I'm trying to go as left as possible. Then I will link this too. This is my approach. This is how I'm thinking right now. Is this wrong? I don't know. Let's see what I'm getting. Right does not exist. Obviously it doesn't. Hmm. Got something. I got 4. What if we have something to the left? This is fine. Now I can do what? I can do value dot left and store node dot left. इसके लेफ्ट में जो वैल्यू है, let's see what do we have. Done. Now the only thing I have to do is connect these. पर कैसे? What if it's null? I should probably just delete node and BST. Locating the node, handle the deletion. If the node has no children, simply remove it. Fine. If it has one child, replace the node with its child. Fine. So if we have two, in order successor, the smallest node in the right subtree. This is what I'm doing. I found it. Replace the node to be deleted with the in order successor. This one. With this one. So we're deleting 3 ना? अरे तो 1/4 के लेफ्ट में आ जाएगा. अच्छा, अलग मेथड से किया है. Oops. Fine. By the way, what is node? Should it still be 3? How can I link this now? And what? It also has some left. Let's make it none. So that node dot right 4 and I should also have this thing. Fine. I just have to link this with the root, with a node above. Should I make another function to do this? Let's replace. If I do node equals to this, then I don't think this will work either. I will have to go here. This function will have node, obviously. I'll pass 2 of the values. Let's say I'm passing root, and I'll also pass node that I have to append. This way. Now I have to go left and right. Wait a minute. What do you have to call that function when you find the node? Programming start. यार जो मनो वो सीख लो. Language सीखना is very easy. You can try Python. Python is very easy. Or maybe C++. I will do this later. At least. Am I going to get this? Pass. Let's see. I got something. I got 5. This is what I wanted. Now I can do the thing is so let's see what's root. It's 5. If I go left, I should have 4. Fine. If I go more left, should have 2. And rest will be none. I can try this one. Let's see. Okay. True. So if not node, that means not found. I can return root straight away. Or let's say node is found but it doesn't have any left and right. What if I only have one node and it is in the key? Same situation if I don't have any left and right. Then I have to return, basically delete that. In this situation, I will get 5 from A. Node will be 3. So if let's say in that case, I can do what? I can do a dot left equals to null. That should do all the job. Return root. Easy. Node का हो गया. So now if it only has, let's say, one child, by the way, my code is like A for apple. हाँ मेरे भाई. So if any one of them, so if I have 2, just link, or if I have 4, just link, right? Hello brother, college is MAIT. So if there is no left, that means I only have a right node. I can do a dot left, and I can push node dot right. That's it. One of the worst code I have written. Here second year हो गया, अभी third year है. What is the issue? This thing? अच्छा. Accepted. My god, if that works. It shouldn't. So in that case, I will get this as a node. If not, wow. हाँ डेली कर रहा हूँ फिलहाल तो. स्ट्रीम का आई डोंट नो, वो तो जो अगर मुझे करनी होती है मैं कर लेता हूँ. कोडिंग तो रोज़ कर रहा हूँ डे से. If key matches, so node I will get this. But what if it's null? Let's write this below. So if I got node which is equal to root, in that case, I think wow. Not a good idea. if root is a key, and left and right doesn't exist. ये शीट मिल जाएगा यार, सर्च कर लो, हाँ गूगल कर लेना, मिल जाएगा। टेक यू फॉरवर्ड स्ट्राइवर शीट। So first of all, I have to check if root and node are equal or not. But in that case, what should add? Is 5. Okay. What I will get if these two are equal, node and root. It doesn't handle that case. $21 should be left to 26. What? $33. Then we have 21. And we have 12. Okay, 27. 33 here, 26. I think 18. We'll have 12 here, that's it. Right. Maybe your not used version. with this. No. Fine. If I'm here, it should not store none. So this will go through all the traversal. Now, when I'm here, I have to check if dot value equals to key. By the way, key can be anything. Node also. I need parent access. I should probably check here itself. So after I append these values, for now let's create a random list. I'll see what I have to do, and let's append the node. So in this case I will have 3 stored, which I absolutely want. Another thing I want is 5. So I will have 5 and 3. Probably. Should I run? Why don't I try this here? PS3. Has no attribute. So if it's none, then on the first index I should have 5, on the second index I should have 3. But what if it's null? I won't have anything then, right? Also get an error. Let's do this. Wait, put this and paste it here. So yeah, cool. Makes sense. What if I have 0 and 3? Basically, if I'm doing 5, key is 5, so I have 0, 2, then 5. So I should have 0 and 5. What I'm doing? Yeah, this makes sense. What was the edge cases? So if we have 0 here, what we have? We should have 0, that's it. It doesn't have anything. Yeah, so if I don't have anything at 1th position, that means root is the node. And if it's null, that means it just doesn't exist. In that case, okay, root is the node. Got it. Now I can play around. can do something like now I can create a function to replace the values. So what I need now, I have this and this. Now I can connect these two if exist to this. So if ARR sense. Let's say I don't have 1, I only have 0. In that case, root is going to be In case of root, again I have to make a function. I need to find the leftmost so that I can link these. Let's do that first. The fuck? Fine. I will get the leftmost. I only need left node. So now if I call this function, let's say find left and need to push first element. What is leftem? Should be 4. Huh? Really? Fuck. Hmm. अच्छा. First indexed. Get this. I have to return the kth smallest value. All the values in the notes. Was it that easy? So we have 1, 2, 3, 4. 1, 1, 2, 3. So first of all, it's easy to do, but this should be optimized. Why? If k is 1, is there anything specific? Number of nodes is n. They are not negative, at least. also positive. First of all, I can store all the values in an array, then I can sort it. I can output the index. That is a possible way, but less frequently. How would you optimize? If it's 1, I have to go all the way left, 3, left. Doesn't make any sense. What if I only have this and k is 3, then 6 will be the answer. I can do it this way, but I'll see if there is any pattern. Works just fine. See what is empty list. Also do one thing. I can sort. One, two, three, 4. I can easily get the answer, but without sorting, it'd be 3, 1, 2, 4. 3, 1, 2, 4 makes sense. 5, 3, 2, 1. We have 4, 6. What is it? It's k minus 1. There should be something better. There are hints given. Look at property of a BSD, but how can I utilize it? I can go to the last one. This will be the smallest. This will be the second smallest. This will be the third smallest. This will be the smallest. This will be the second smallest. No. Not. I need more examples. First smallest, second smallest, third smallest, fourth smallest. Okay, so try left, root, right. Let's see. I can get something, a clue at least. Let's see. Okay, smallest, third smallest, fourth smallest, five smallest. So now I can just store K. I mean, I don't have to sort now. Wait, time complexity is still the same? It shouldn't be. At least I'm not sort. Whatever. This will be the smallest. This will be the greater than that. Then this will be the greater than the. I think this is solved. You need to find K the smallest. Frequently, how would you optimize? If it's modified. To solve this is done. Check if a tree is BST or BT. I can solve this. When I'll come back later. This is a BST. Smaller. Now this is, I have to store a value of root and I have to see whether this is smaller and this is greater. This has 3, so that's why. Because should be greater. But its right child value is 4. Acha, हाँ ये भी तो है. Let's do this. I can write it here only. Is valid. Let's see if not root. Let's just make a function, no issue. I can use an array. The value is node.val. Check for the left and right. So if node.left, if it's none, then I will get error if this is none. I should also do this for I can't. So if I'm at 6, I don't have to check. Fine. So if not, दोनों में से कोई भी none है, then both will be none. In that case, I can also return. Now, what if I only have one? Only have left, then I have to check for left. If I only have right, then I have to check for right. Let's say left is not here. So in that case, we only have right one. So if we have right, then the value of right should be greater than node dot value. The error at 0th index, this will be equals to 1 for node dot left dot value. By the way, this was very easy if I just use a queue and a level order. See? Can be equal, I don't know. Yeah. All the values are unique, not written. Whatever. So if bright value is lesser than this, then store 0. Else I'll just leave. Case for left, if it's greater than this, then also a problem. That is done. If we have only one, only two. Now if we have both, node key value should be greater than make a ARR an array and print true here, and turn true if this is 1, else false. I'm getting true in this case. Using no dot value everywhere. Left dot value is greater. Wait, ये तो यही हो जाएगा scene. So if this value is greater, which is not. Also if this is greater than this, which is true. It didn't work. I should see what happened if I just append 0. Just pop this shit. Let's swap these two. This is empty. If it pushes 0, then we have a problem. But this should be fine too. I don't know where. Index is out of range. I don't have anything in this. Let me just print. Let's see. Did I just forgot to call the function? Happened to me before as well. But in case of a true, whatever, it's absolutely fine. Don't have to change anything. Just have to call this function, push the root. Can you read the question? Ye wala. Basically, I just have to find whether the tree that is given, it is a binary search tree or not. I'm getting false in that case too. Wait. Why? Be 0. Huh. I should be here, probably. And let's Let's see. Let's call this function root inside, and let's see the value of error. ARR, I mean. We have 2, 1 and 3. I don't have anything in this. Basically it should be true. It's not true. Push 1 here. It's fine. So if it's 1, then return true. But I'm getting false. Wrong. My college is MAIT, and my second year has been completed, so abhi I'll enter into my third year. Should be fine. I need a it's fine. Is there a reason why this is happening? So if I'll tap any random shit here, say error of 0 equals to with 0th index. I think this is a better option, but it's the same thing. It should replace. So it's working just fine. I don't know what's wrong. Let's see the answer. But then I have null in this case. What? Why do I have null? Abhi, maybe you should just explore different things. Do some DSA, do some ML, do some web development and see what you like. I'm getting false because this array is a problem. Valid node, it's fine. Use node everywhere. Let's see. Is there anything wrong? No, not at all. Bit 213. It's literally the same code. There is no difference, but still. False and true. This is absolutely fine. Let me write this other way. If this is equal, then return true, else return false, right? Same thing. I don't know. There is no reason. I cannot see. I got null. In this case also I got null. This was true now. Wait, what? Something is wrong. Something is wrong. No, this is false. Acha, problem is bit true, not false. You can write a recursive solution, like you can check left and right subtree. Valid or not. If they are not valid, return false at return. Some kind of that. This is exactly what I did. It is basically the same thing. There is no difference. Let me diagnose this a little bit. So now I got true for both. This is not working at all. Basically this is not equals to 1. I'm not popping. Not doing anything. Should be just fine. See, I got null. Got false in both. Basically this is not 1 and I don't know why. Maybe I can try this appending. If something changes. Doesn't matter, right? So if we have 1, then return true. Why this worked and it doesn't make any sense. Those were the same thing. If they are equal, here we go. Expected false. So this is not a BST. I got it. I mean, well, if equal, then also a runtime error. What? Is this wrong? This is fine. In this case, I got true. 4, 6. This is fine, but this is fine and this is also fine. But this 3 should be bigger than 5. Okay. I have to check for a whole subtree. Can do that. I can use first value check in the whole trees. I can do it recursively. Let's check. Let's take a node and a value, and so here value should be greater. Here value should be lesser. So let's say check for the left. This will go to the left. It will check whether all these values are greater. So if it's greater than 5, then it's fine. Turn false. Case of left if it's greater. Return. Will I get false if this is the case? So if I get false, I'm not storing anything. Let's see, a equals to, so false if anything is false, then return false. And this is none. Fuck it. Not matter. So it's true. Okay. I will get false. Can write same code for the right subtree. Oh. We'll do the reverse check. We're safe. I should probably try to use this. Okay. Let's check. Let's push 5.right. Let's go. Return right. I can take root.right. Push 6 and let's see. So it should be false answer. Okay, we also need value. So what is value of root? It was 5. Yeah, pretty much. Hello. I should get false. I'm getting false everywhere. ये तो true है यार. इस बात का false. अच्छा, I'm pushing 5. Let's try to see this thing. Yep. I don't know. If it's equal, then also just I should get false. This is true because he is bigger than 2. Why is this false? Because it has this 3. It also has 3, that's why. Now I have to write a function which goes through every single node, calls this function out, and yeah, Should I just do DFS? Do we have this root? Not root. And return. Let's go DFS. Root dot left. Now for every single root, I have to go left and go right. Also do this. This will help. So I'll go left, and this is a left function, and I can push root dot left. What if it's none? It should return true. Fine, absolutely fine. So I can push root dot value. This is also good. And here I can go to the right and push the value. I will get something. Should either be true or false. So if if both are true, then only move forward. Else you can return false. But what about this thing? This will return true. Look at A. And anything is false, then return false. So there is no problem. Let's try to return DFS of root. There is no value. I cannot store boolean values. It bugged. It's working fine with although I'm not using any memory, right? Time complexity is higher. Not an optimized solution. Picking a tree, going left, going all. It should be n squared maybe. In a worst case, versing this, then here I'm also doing everything again. Yeah, it's n squared. What is the optimal solution? अच्छा, I could have done this too. Actually completely makes sense. थोड़ा आइडिया तो लगा मुझे. I have to. I can always push, right? So in this case, I can have two values. So I can have 5 here. Be smaller than 5. Calculator should be smaller, fine. But over here, when I'm at 6, I have 5 as well. This should be greater than 5. When I'm at here, I should have this 5. Makes sense. Let's try to do this. Give it a proper name. And these variables should be passed. Let's take A and B. Now A is nothing but root dot value, but B should be passed. Both. I'm gonna pass both of these. So this will be root dot value. ये सॉन्ग प्ले करो, मैं इसे लगाकर ही सॉल्व करता हूँ. ये सॉन्ग what are you trying to say, bro? By ये सॉन्ग, ये जो चल रहा है बैकग्राउंड में, are you talking about it? Whatever. अच्छा, I'll see. Take left and right. You are here, then should be greater than 6. The whole subtree. You are here, then it should not only be smaller than 6, but also greater than 6, 5. भाई इससे कॉपीराइट नहीं आएगा? शाम सवेरे तेरी यादें आती हैं, आके दिल यूं तड़पाती हैं. बैकग्राउंड में भी आता है कॉपीराइट ब्रदर. ये गाने क्यों सुना रहे हो तुम मुझे? आ, ठीक है, स्ट्रीम के बाद सुनता हूँ, अभी तो नहीं। तो 75 सॉल्व कर दिया है जावा में। सही है भाई, लगे रहो। I think another thing I can do is, in this case, when I'm at 5, I can store both of these in 4. Then, first of all, when I'm at 6, they should be greater than 6 and also greater than 4. They're not greater than 4. But if they are 4, then it's fine. What is the problem basically? Could be 2. This could be 5 as well. But if it's 4, 4 is also fine. 4 is not fine. What? 5 से बड़ा चाहिए. 5 is also, I don't think 5 is acceptable. Should be greater than 5. Maybe 6. Helper function लो. You know what? I have solved a lot of problem, but मैंने specifically helper function कभी पढ़ा नहीं. अच्छा, ये होता है. एक सॉल्व तो मैं ऑलरेडी कर चुका हूँ. एन स्क्वायर रिकर्जन से चेक करो, -infinity to infinity. कौन सा कॉलेज? MAIT। कहाँ पर? दिल्ली में। This was my solution, by the way. Not this one. Just implemented two functions to check the subtree. Then I called those functions for every single. I should probably just check. So if how does this work? You're just checking for if left is greater or right is. When you go to the left and you pass the same left limit, pass the value of node, which is 4. Will pass the value of node and right limit. When you are at 3, I've also used AND. Sure, I can do this. But from writing if condition. So at 3 I'm going to write. Going right I have 5. When I'm going left I have 6. So at 3 I have both 5 and 6. Be greater than both. So at 3 left limit be 5. Be greater. Wait, what? P should be greater than 5. Makes sense. And what is right limit? If we have, let's say, 7 के पीछे if we have 4, we would have 6 and 7. Should be greater than 6. 4 is not greater than 6. Acha. Also write optimized code. So I have left and right. I can do if the value of root, if it is greater or equal. So let's say I'm here. So checking for a node, right? Should be greater than left to right, or if it's greater than right, or root.val is lesser than or equal to left. In both of the cases, return false. Or what I can do, call this valid function with the root.left. So when I will go left, I should have, I can pass this, I can pass the value of the root. If I'm going left, I should have 5. And root.value as a right. It will check whether this is greater. It's not. And also, if I'm going here, this is my left, it will be root.value. Right will be the same. I can use same logic. To be passed here minus Okay. For 2. Two is greater than what? When I'm going right, what I did, okay, this is the one. It's same, yes. %34% acceptance rate. Oh, how we did this? By taking two variables. We have this. You can decide for this. I'm going right and right. I only have value should be small. Greater than infinity. Probably last question. Lowest common ancestor. So 2 and 8 should be 6. If we have 2 and 4, then it should be 2. In a minute, I'll be back. Hmm. Lowest common ancestor. I will have to find. I will have to find 6. I'll go left. I'll go right, and I'll see if I can find it. This case 2 and 4. So here, both of these in our left subtree. Now go like this. Note to be a descendant of same thing. Then कैसे किया था solve? I wait. We have 2 and 3. We will have 2. Root is 6. E is smaller, Q is greater. Then obviously root will be the answer. In this case, both of these are smaller, so obviously this will be at left. The moment I will find any one of these, I'll just keep checking. दोनों में से कोई भी लेफ्ट एंड राइट हाँ, this is not working. First of all, I will check. But it is not like P is smaller or Q is smaller, right? Q is always bigger than P. Let's do this thing. Let's do P is minimum of P and Q, just to make sure. And the minimum, this thing is sorted, and they are going to be unique, not equal. Cool. Let's traverse and check. Wait, लो है क्या? नहीं कर रहा। एक माउस ही खराब है। इनको